Let's practice balancing two more redox reactions in acidic and basic solutions, and then move on to electron potential. So here we're provided with a redox reaction. We have to identify the oxidation half reaction and the redox half reaction, and then balance all of the atoms as well as the electrons. And so this is always initially, whether you are doing it in basic or acidic solution, you should always start by doing this in acidic solution and neutralize after. But step number one is assigning oxidation numbers to all of the atoms. The easy ones are the ions that already have charges by them. So those are iron and manganese. And the only thing we have to worry about is the manganese on the reactant side. And it's +7 in this case, so it is reduced. 5 electrons are taken up and go from +7 to +5. So now the easy one is the iron 2+ is oxidized to iron 3+, and so 1 electron is ejected here. That is the oxidation. The reduction is the permanganate. That is an NMnO4-, and 5 electrons, which of course come from iron, so we have to balance that later. But first we identify the reduction and then make up for the oxygens that we have. And so this is the reduction, and so now we balance oxygen, and so we have and hydrogen. And so oxygen, we have 4 on the left, so we add 4 water molecules on the product side, which of course now gives us 8 hydrogens on the product side. So we need to add 8 hydrogens in the form of acid on the reactant side, and so now all of the atoms are balanced other than iron and manganese, which were already balanced. And so the next part is to balance the electrons. So we need to multiply the iron reaction by 5, which of course means we get 5 iron ions and 5 iron ions and then 5 electrons. So now we can pull it all down, add them together, everything on the left. We start out with 5 iron 2, and sorry, I needed to add an 8 here because we have 8 hydrogen, so I actually need to add 8 hydrogen ions on the left, so we still have them 8H+, and then the permanganate. I'll keep wanting to make something new out of this one with an M there, and 5 electrons goes to 5 iron 3+, 5 electrons, and then manganese 2 and 4 water molecules. That's balanced now. Let's count all of the atoms, but also the charges. So we have 2 iron 2, that's a +10, and then we have 8 charges from the hydrogen, and then we have that manganese charge. This gives us an overall 17+ charge on the left. We need to have a 17+ charge on the right, so we have 3 times or 5 times 3+, which is 15. Okay, so we're going to take out the electrons before we balance that. And then we have a +2 charge from the manganese, which is also 17+. So the electrons are not the electrons, the charges are balanced, the electrons drop out. So we did this properly. All of the oxygens are, we have 8, we have 4 on the left and 4 on the right, but I'll let you go through this yourself. And then if I was to do this reaction, here's just the summary, but if I now was to do this in basic solution, all I need to do is get rid of or neutralize the 8 hydrogens here, and so that's what makes this acidic. And so in order to neutralize them, I have to add 8 hydroxides, and so we add 8 hydroxides on the product side as well. Need an 8 here just to make it even. Of course that turns that makes 8 water molecules. And since I have 4 on the product side, they drop out. This gets reduced to 4. And then I just have to pull it all down. And so I have 4 water molecules, so nothing happens here to the iron, and nothing happens to the permanganate. And then I still have 5 iron, 3, 1 manganese, and then of course the 8 hydroxides I added earlier, and the waters are dropped out. And so now if you do the atom count and the charges count, it's still all balanced, right? So this here, I kind of try to guide you what I'm doing here. You add 8 hydroxides first to neutralize it, and then you have to do this to both sides here. Of course, that turns the hydronium ions, or the H+ ions, into water, and then we have 4 waters that are gonna cancel out, and this is the balanced equation here on the bottom. Let's do one more and then move on. So here is example 19.3. We have iodine and permanganate going to iodide, and manganese for oxide. Assigning oxidation numbers, this is -1 and this is 0. This is also the same thing. We just looked at permanganate. We have +7. This is -2, but here manganese is +4. And so we're looking at 3 electrons for the reduction now. So we have iodine, and I might as well balance that right away because I'm producing 2 iodides. So this is the oxidation. We have 2, and it loses 1 electron per iodide. So you have 2 electrons, that's your oxidation. The reduction is MnO4. And as we said, we going from +7 to +4, so we have 3 electrons here. That would be the reduction. Manganese oxide, that is the reduction. So now we balance. This is supposed to be done in basic solution, but we need to balance in acidic first and then neutralize. So we have 2 oxygens on the product side and 4 on the reactant side, so we add 2 water molecules to balance the oxygens. Then we have 4 hydrogen ions, and so, or atoms, and so I add them in the form of 4 hydrogen on the left. Okay, so this would be then, if I pull it together, and let's do that real quick here. I have 4 H+ and MnO4 minus, and 2 iodide, and 3 electrons. So I still have to balance electrons. I forgot that, but that's no problem. I can do that here in a minute. And then I have, let's finish this first. I have I2 and 2 electrons and manganese oxide, and then 2 water molecules. And so the problem, of course, is that my electrons don't drop out. So I made a mistake, but you know maybe this is just to demonstrate that how you can catch your own mistakes, just like I did just now here. So I'll have to multiply this by 3, and I'll have to multiply this by 2 so that I get 6 electrons. So when I do that, let's do this carefully now, right? So 3 times 2 would make 6 iodide plus 8 hydrogens plus 2 times MnO4 minus plus 6 electrons going to, now I'm going on to 3 times iodide, so 3 I2s, and then of course 3 times 2 electrons is 6 electrons, which is what we want. And then I'm multiplying the reduction reaction by 2, so I'm on the product side already. So I need 2 manganese 4 oxides and then 4 water molecules. But unfortunately I am not done, and you can also check your charges at this point and your total atom count. I'll let you do that yourself. Everything is correct here, and so to neutralize I would now add 8 hydroxides. If I add 8 hydroxides I get 8 water molecules here, and I add, it's a little far apart, but I have 8 hydroxide, and so now the water molecules 4 drop out, so I get 4 water molecules, but I keep the hydroxide. So now that's balanced in basic solution. Let's go to the next page. It's pretty busy, but it's cleaner. So we already are down here, and then here's just the total count of the charges. We have 8 negative charges on the right, and so we have 2 times -1 and 6 times -1, so that's also -8. So the charge is balanced, and anyway, I'll let you go through this by yourself, but here are all the steps that we just went through. All right, when we come back, we're going to start making batteries and electrochemical cells with these.